Welcome back to the channel, guys, in this short video on aspects of drone flying, where we'll be looking at issues such as wind speed, wind direction and wind resistance. As part of this video insight, we are going to look at aspects of weather forecasting and a useful tool on Google Maps giving real-time weather data updated closer to your audit site than what you might actually think, using a system called APRS, or Automatic Packet Reporting System. In respect of wind, we'll also take a little look at wind resistance and drone tolerance and identify the limits of responsible drone flying up to Force 5 or Level 5 on the Beaufort scale. Typically, wind direction is given from where it is blowing from, not to. Hence, in my flying rucksack, I always keep a small compass in which I can orientate my face to. Flying of any kind is all about using the senses and an acute sense of situational awareness. So there are various clues in the environment if we look carefully enough. For example, if we look at wind vanes or windsocks close to industrial buildings or airports, these can give a clear indication of where the direction is coming from in the absence of a compass. In the absence of vanes and socks, there are sufficient clues in the environment to indicate the wind around you and the drone. Notwithstanding, the behaviour of wind at altitude can differ to that on the ground. The following slide illustrates situational awareness in relation to any sensitive structure and as to whether you fly the drone upwind or downwind from it, which should be an entry into any good drone log. Remember also, if your drone's wind tolerance is overcome, it is not only a lost drone, but it is a compulsory report to the CAA as a fly-off. The units of wind speed are given in any number of forms, which include imperial, metric and knots. So it's therefore probably good practice as part of any flying kit to include a few laminated charts in your rucksack, which will allow you to interconvert the units should the necessity arise, rather than try to do this on the hoof when you are overburdened with the flight itself. Many of these tables can be found online and can be downloaded and laminated. It's probably also good practice, if you take your drone flying serious, to purchase a little small handheld anemometer, but always remember that the wind speed in the air can vary markedly to what you're measuring on the ground, but nonetheless such a little meter gives an indication of the ground speed and whether it is in fact appropriate to take off at that point in time given the wind conditions. The following slide attempts to explain the difference between wind resistance and wind tolerance. Wind resistance is the force of the wind against the drone, whether it be a light breeze, a moderate breeze, a gale or a storm. It is that force that the drone has to overcome, and the wind tolerance of the drone is dictated by the power of its motors and the thrust at which it generates, as well as the mass and its shape and other factors. In terms of out-of-the-box flying, many of the DJI Mini Mavics will issue a wind warning. However, common sense dictates, why would you send the drone up in the first instance if the wind conditions are not acceptable? Another consequence of flying against high wind resistances is the life of the battery and the flight time, which will rapidly diminish as the motor stabilises and fights the wind resistance. Aside the obvious consequences of flying a drone in high wind of a fly-off or a lost drone, here are some of the consequences that you're likely to see or experience. Remember, drones are machines and machines can fail. So if in doubt, don't send it out. Come back and do it on another day. Before we go on to look at wind tolerance in more detail, that being very important to the flying of it, we look at some factors influencing the tolerance rating, and those include the weight of the drone, the power of the motors and the thrust generated, as well as the shape of the drone and the controlling software, all factors which will influence the drone rating. We also identify two common drones, the DJI Mavic 3 and 4 Mini, where the 4 will issue a warning at 10.7 meters per second or 23.9 miles per hour, which is on the level 5 scale, which we'll be looking at next. The Mini Mavic 3, on the other hand, issues a warning at 7 meters per second or 15.6 miles per hour, meaning the motors in that particular model are a little bit less powerful than. The following slides give an indication of drone tolerances for a range of commercial drones. In the main, it's generally accepted that the level 5 mark is the limit for commercial flying, although there are some models that can extend beyond that. It is important that you realise what the drone tolerance is of the particular model of drone that you have. Drone tolerances are therefore equated to a scale known as the Beaufort scale. So in the next series of slide run-throughs, we're going to go through a musical accompaniment of the Beaufort scale and drone tolerance levels in terms of the effect in the environment. In the next two parts of this little presentation, we're going to look at two methods of getting real-time updated data close to the locality in which you're going to take off or land. We're going to look at first APRSI and then we're going to look at ATIS. And we'll deal with both of those things each in turn. And I hope you find those tools a very useful addition to your skills. Okay, so we're now going to return to APRS automatic packet reporting system, which is effectively a radio frequency transmitting data, including GPS, as a packet. What we are actually going to do now is to look at the APRS.phi map to look at the various weather stations scattered across the United Kingdom. The APRS.phi map is available on Google. Please allow it lots of time to load because it's incredibly rich with data and information. The map itself is very similar to the Flight Radar 24 maps for tracking aircraft. And as you can see, you can track vehicles with APRS radio and shipping as well. But for the purpose of this exercise, we are interested in the little round circles with WX, which is a randomly scattered array of weather stations across the United Kingdom. This is not necessarily an absolute way of getting local weather data, as it depends on how close the weather station is to the proximity of your audit, as well as how often the weather station updates itself. That usually occurs with every 3 hours or less. I've included a couple of snapshots of the APRS mapping in the slides that you're looking at, predominantly for the north of England and the south of England, but these of course can be zoomed in and refined in terms of data that you want to extract from them. Before we click on the WX button, revealing what goodies lie inside in terms of historical and current weather data, we'll have a quick look at the format of the weather station, which sometimes you may see as you travel along the motorway. The weather station is connected via the Internet of Things and can contain an array of sensors ranging from wind speed measured by a anemometer, temperature, humidity, as well as rainfall and other weather parameters. Those parameters, such as atmospheric or barometric pressure, can not only give you the position of the weather at that time, but it may well give an indication as to how the weather may change in the immediate future by looking at the barometric pressure recording. Wind speed and wind direction may also give you an indication as to whether it is favourable to fly your drone before you make a journey. So I'm going to leave you to discover APRS on your own. I'll give a few hints to its use. So for example, I've selected a random weather station, as you can see from the map. I've then clicked on the round circle, which has brought up an option box, and in the top right hand corner it says weather. I've clicked on that box, so it brings up a series of graphs. If you scroll through them, the graphs are fairly self-explanatory. Each weather station will slightly vary with the sensors they have, but on this particular one there is barometric pressure, rainfall, wind speed, wind direction and luminosity, which is also quite a useful thing to have. So there is a various. You will now have also realised that the wind direction is given as a compass bearing. So for example, due west is given as 27 degrees and due east as 90 degrees. If you really wanted to go to town on weather data, you could even download the telemetric data from high altitude weather balloons, occasionally released across the country by the Met Service. I hope you find this little section of interest in identifying ways of finding real-time local weather information, which is updated much quicker than a predictive weather forecast. So whether or not you find this tool useful remains to be seen, but clearly annotating some of the printouts into drone logs is a very good way of protecting yourself to ensure that you are keeping good flight records. So we're not quite done yet on local weather, and in this next section we're going to look at the use of ATIS using radio scanners to get real-time radio reports from localised airport terminals that may be close by or in the vicinity. Another way of getting real-time weather information as a radio report is to tune in to the nearest regional airport's ATIS frequency, where you will hear a weather broadcast. ATIS, or Air Terminal Information Systems, is an updated daily weather report produced by the tower or air terminal. These can be accessed readily using handheld scanners operating in and around the 108 to 132 MHz VHF band. These regional or local aerodromes may give you some insight to what the weather conditions are like in close proximity. The following is a selection of standardised ATIS weather reports from a number of international airports, where the weather information is presented in a standardised form.
Houston Intercontinental Airport information Delta 1753 Zulu. Wind 170 at 10. Visibility 5. Light rain, mist. Ceiling 800 broken, 1700 overcast. Temperature 17, dew point 16, altimeter 3000. Arrivals expect ILS Los Angeles International Airport information offer 2353 Zulu. Wind 260 at 13. Visibility 10. Few clouds at 8,000. Temperature 21, dew point 13, altimeter 2984. Ramar. AO2, sea level pressure not available smoke. Few clouds 8,000, 102220202056 ILS approaches in Airport information Romeo 2217 Zulu Special. Wind 090 at 13. Visibility 1/2. Mist. Ceiling 300 overcast. Temperature 16. Dew point 15. Altimeter 2992. Remarks. Surface visibility 1 3/4. Arrivals expect ILS runway 8 right. Kennedy Airport information Bravo 1651 Zulu. Wind 140 at 9. Visibility 10. Few clouds at 10,000, 14,000 scattered. Ceiling 25,000 broken. Temperature 21, dew point 13, altimeter 2986. Approach and use VOR DME runway 22 left, VOR runway 13 left. Departing runway 2. Minneapolis St. Paul International Airport arrival information Echo 1753 Zulu. Wind 170 at 8. Visibility 6. Mist. Ceiling 500 overcast. Temperature 2. Dew point 0. Altimeter 3003. Parallel ILS approaches runways 12 left and 12 right in use. Final approach over noise sensitive area. Notices to airmen. Runways 4.
Okay guys, so let's round this video off by saying a few quick words about weather forecasts. Weather forecasting apps are widely available, however the accuracy and precision of them is always debatable. There is really, in my opinion, no substitute for real-time data updating at a local source close to where you're conducting your flight. As always guys, I will place some useful and relevant links beneath the video in the description. In the meantime, please help this channel grow by liking, sharing and subscribing, and hope you will be able to join me on the next video where we'll be looking at other aspects of drones in terms of flight logs and various tools similar to what we've looked at today. So thank you very much for listening guys, and please don't forget, like, share and subscribe.